Good afternoon, everyone. I am Jessica Mangawan and I will tackle about the modern algebra together with Mariel Bataluna.
I am Mariel Bataluna and today I will tackle about the number theory and its types. So bear with us until the end of this video. The two defendants were pleaded both non-guilty, Your Honor. Start the trial. Are you really sure that you don't know the modern algebra? Even a little bit information about it?
Yes, I don't know what is that.
If you really don't know about the modern algebra, why did these things are in your bag?
It wasn't mine. It's obvious that someone framed me. I promise I don't know about it. It wasn't me. I'm innocent.
Are you sure? Every suspect would say that. The plan to tell us about the number theory and its subfields. It might help you to lower your case. I told you so many times. I didn't do it, and I don't know about the number theory you're talking about. Now, do you have the plan to tell us everything you know about the crime?
If I tell you the truth, I am still going to jail?
Yes, you have to pay for your sin.
Okay, I will speak. It was her fault. She said that we can easily make it if I study the modern algebra, so I did.
What do you mean by modern algebra?
Modern algebra, or also known as abstract algebra, is a branch of mathematics that concerned with the general algebraic structure of various sets such as real numbers, complex numbers, matrices, and vector spaces, rather than rules and procedures for manipulating their individual elements. On the other hand, an algebraic structure is a set called carrier set or underlying set with one or more unitary operation defined on it that is satisfies a list of axioms. Abstract algebra study algebraic structure includes groups, rings, fields, modules, vector spaces, and algebras.
What are the examples of the algebraic structures? What does it mean?
As I said earlier, it includes groups, rings, fields, modules, vector spaces, and lattices. A group in algebraic structures had a set of set and binary operations that one more set and operations. The ring and algebraic structures, it's a commutative property, quantity of A plus B equals B plus A, and the associative property is brackets A plus quantity of B plus C equals quantity of A plus B plus C. Paired is a set in which addition, subtraction, multiplication, and division are defined and behave as the corresponding operation on rational and real numbers do. Also, a module is a generalization of the idea of vector space where a ring is used in place of the field of scalars. Due to the fact that abelian groups are exactly modules over the ring of integers, the concept of module is also a generalization of the idea of abelian group. A vector space, also called a linear space, is a set whose elements, often called vectors, may be added together and multiplied by numbers called scalars. And the last one is the lattice. It is an abstract structure studied in the mathematical subdisciplines of order theory and abstract algebra.
You can't lie to us now. Your partner told us everything. Now, tell us about the number theory. Okay, I'll tell you the truth. I let him study the modern algebra, and I will study the number theory to do our plan. Number theory is a branch of mathematics that studies the characteristics of positive integers like 1, 2, and 3, often referred to as higher arithmetic. It is one of the oldest and most intuitive branches of mathematics. German mathematician Carl Friedrich Gauss said mathematics is the queen of the sciences, and the number theory is the queen of mathematics. And lots of number theories study the prime numbers as well as the properties of mathematical objects that made of integers. Both professional and amateur mathematicians have always been attracted by number theory. All the solutions to the issues and proofs of the theorems frequently need for a sophisticated mathematical background. Number theory problems and theorems can often be grasped by lay people, in contrast to other disciplines of mathematics. Until the mid-20th century, number theory was considered the purest branch of mathematics with no direct applications to the real world. Elementary number theory, algebraic number theory, analytic number theory, geometric number theory, and probabilistic number theory are some of the subfields of modern number theory. The approaches taken to solve the integer-related problems are reflected to these categories. Are those subfields? Can you elaborate to us? Elementary number theory is the branch of number theory in which elementary methods are used to solve equations with integer or rational solutions. An example of a problem which can be solved using elementary number theory is the classification of all Pythagorean triples. Algebraic number theory studies the arithmetic of algebraic number fields, the ring of integers in the number field, the ideals and units in the ring of integers, the extent to which unique factorization holds, and so on. Analytic number theory is the branch of number theory that attempts to solve problems involving the integers using techniques from real and complex analysis. Many of the problems that analytic methods are well suited for involve the primes. Theorems in analytic number theory are often about the behavior of some number theoretic quantity on average or when some parameter is very large. Geometric number theory is a branch of numbers theory that studies number theoretical problems by the use of geometric methods. Geometry of numbers in its proper sense was formulated by H. Minkowski in 1896 in his fundamental monograph. And the last one is the probabilistic number theory. It's a subfield of the number theory which explicitly uses probability to answer questions about the integers and integer-valued functions. Also, a significant portion of probabilistic number theory can be viewed as a specific instance of the study of variables that are nearly but not quite independent from one another. For instance, if a random number between 1 and 1 million is divisible by 2, It is almost independent if it is also divisible by 3. It has been claimed that probabilistic combinatorics makes use of the idea that anything that has a probability larger than 0 must happen at some point. Similarly, many applications of probabilistic number theory rely on the idea that anything that is unusual must be rare. It follows that there must be few of certain algebraic objects like rational or integer solution to particular equations, if it can be demonstrated that they are in the tail of certain sensibly defined distributions. This is a very concrete non-probabilistic statement that follows from a probabilistic one. That's all that I can give you. Your Honor, the two defendants were both pleaded guilty for their crimes. The two defendants, Jesse Kamingawan and Mariel Bataluna, are sentenced to be at least 5 years in prison. Case dismissed. Order of the court.